Okay, in the Haber process, that is the industrial method for the synthesis of ammonia. Synthesis of ammonia already we have discussed. Now let's see chemical properties of ammonia. Already in the last class I discussed the important chemical property of ammonia is it has basic character or basic nature. So how can we identify ammonia is basic character? So whenever ammonia in water or ammonia is present in water, it forms hydroxyl ion. So due to the formation of hydroxyl ion, ammonia has basic character, as well as ammonia reacts with the acids HCl, they forms ammonium chloride, salt. Means acid and base they combine to produce a salt. So that's why due to these chemical properties or due to these reactions, either formation of hydroxyl ion in water, ammonia has basic nature or NH3 is a base. And NH3 also acts as a Lewis base. What is Lewis base? Lewis base means what, ma'am? The substance can donate pair of electrons to the deficient atoms or deficient molecules, then they form N2 bond or coordinate covalent bond, then the substance are called as Lewis bases. So while NH3, in NH3 or in ammonia, nitrogen is central atom, it contains lone pair electrons. Okay, so this lone pair electrons donates to the BF3. BF3 is electron deficient molecule. It acts as a Lewis acid. So electron deficient compounds are called Lewis acids. So they accept a pair of electrons from ammonia and they form a bond between nitrogen and BF3. Generally in NH3 hybridization is sp3 and pyramidal shape, and in BF3 boron trifluoride its hybridization is sp2 trigonal planar geometry, but after bond formation between that Lewis acid and Lewis base, the NH3 covalency becomes 4, means but here this covalency is 3, means before reaction the nitrogen covalency in NH3 is 3, but in after bond formation between NH3 and BF3 its covalency becomes 4, and sp3 hybridization the shape is tetrahedral geometry. Come to that BF3, instead of 3 bonds 4 bonds are present, then the covalency is 3, sorry, covalency is 4, but here the covalency is 3, no lone pair electrons, because the boron belongs to 38 group element. In its valence shell contains 3 electrons are present, 3 electrons are involving in bonding, that's why there is no lone pairs. But nitrogen is 58 group element, out of that in that valence shell they contains 5 electrons are present, out of 5 electrons 3 electrons are involved in bonding, they have 1 lone pair is present, that's why 3 bond pairs and 1 lone pair. Then total hybrid orbitals are 4, then hybridization is sp3 and pyramidal shape, but here the hybridization is sp3 and tetrahedral shape. Lone pairs are absent, there is no lone pairs because the lone pairs are donated to BF3 and they involved in day2 bond. Now here the covalence is 4, the hybridization is sp3. So among that nitrogen and boron in the reactants and in the products, boron hybridization is changed from sp2 to sp3 and shape also be changed. sp2 means trigonal planar geometry, and here the tetrahedral geometry. Geometry and hybridization both are changed in boron atom in this reaction. But nitrogen hybridization is same, but geometry is changed, and covalency is also 3 becomes 4. Okay, these are the important points related for objective in this concept. Now let's see the formation of complex compounds. Ammonia can able to form complex compounds with certain compounds. See what are the important reactions for the formation of complex compounds. The first one is whenever ammonia reacts with silver chloride, AgCl. For this, the formation of complex compounds, ammonia in water forms ammonium hydroxide, NH4OH. Okay, Let's clear. Now this ammonium hydroxide involved in bonding or involves forms day-2 bonds with some of the compounds and forms complex compounds. For example, the first one is silver chloride, AgCl. Generally, initially AgCl is white PPT. White PPT. After it reacts with ammonium hydroxide, NH4OH, they forms AgNH3 twice Cl. This is the complex one, soluble complex, colorless, soluble complex. It forms colorless soluble complex and byproducts are water. 2 moles of water will form. See, AgCl are silver ions. You take directly Ag plus ions, then forms 2 moles of ammonium hydroxide, forms complex Ag and H3 twice plus. Okay, plus 2 moles of water. Means positive complex compounds will form. AgNH3 twice Cl or AgNH3 plus. What is the charge on the coordinate sphere? Positive charge is present. So initially silver ions or silver chloride is white PPT. After they react with ammonium hydroxide or ammonia, they are converted into complex compounds. That complex compounds are soluble and colorless. Okay, so this is the test for identification of silver chlorides. The next one is, we know very well, anhydrous copper sulfate. Anhydrous copper sulfate is a colorless. But this anhydrous copper sulfate reacts with ammonia. It reacts with 4 moles of ammonia, then Cu NH3 4 times SO4. It is a deep color solution, deep blue color solution. This complex has an existing deep blue color plus water molecule. So copper plus 2 ions. What is the charge on this? Copper sulfate, copper plus 2 ions. Anhydrous copper plus 2 ions. They are combined with ammonium hydroxide, forms a complex compound. It has blue color. It has a blue color. So this ammonia is also useful for identification of silver ions as well as copper ions, and they form silver ions and copper ions. They react with silver ions and copper ions, forms complex compounds. So these are very, very important one. At the same time, this ammonia solution also forms precipitates with certain compounds, especially for identification of cations. In salt analysis, identification of ferrous ions, Fe plus 3 ions, and identification of Zn plus 2 ions. For that ions, we can identify when they react with the ammonium hydroxide, they form precipitates. Let's see. Fourth one, formation of precipitates. The first one. Generally, ammonia and water is existing ammonium hydroxide, NH4OH. Okay, ma? This NH4OH and react with zinc sulfate, ZnSO4. Reacts with the zinc sulfate, ZnSO4. NH4OH forms zinc hydroxide, ZnOH twice, means 2 moles. This is a white PPT. it forms plus ammonium sulfate. Okay, when they reacts with aluminum trichloride, means aluminum is present, oxidation state is +3. So aluminum ions are present, then the aluminum cations are present when react with ammonium hydroxide, forms ALOH thrice. Aluminum hydroxide is white gelatinous PPT. White gelatinous PPT plus 3 moles of ammonium chloride. The same way, when this ammonium hydroxide combined with ferric chloride, FeCl3 combined with ammonium hydroxide forms Fe2O3, X moles of H2O plus 3 moles of ammonium chloride. Okay, this is hydrated ferric oxide. Hydrated ferric oxide will forms. Ferric chloride reacts with ammonium hydroxide, forms hydrated ferric oxide. It is a brown color PPT. It is a brown color PPT. So these are some important reactions, precipitate formation reactions with ammonia, and ammonia solution. Okay. Let's see. Next, nitrogen and nitrogen containing compounds. First one dinitrogen we have discussed. Next one is ammonia we have discussed. Then in ammonia, another important chemical property is reaction with halogens. Reaction with the halogens. See, the first one is, especially the ammonia reacts with chlorine and bromine more, but not with fluorine and iodine. When this reacts with chlorine, excess of ammonia, then 8 moles, this is 3 moles, forms 6 moles of NH4Cl, ammonium chloride, and remaining 2 nitrogen atoms converted into N2 gas. See, when excess of ammonia reacts with chlorine, forms ammonium chloride and nitrogen gas. The same way, this ammonia reacts with chlorine. This chlorine is excess. In that case, they convert into nitrogen trichloride, NCl3 plus 3HCl. NCl3 plus 3HCl. The same way, either in the chlorine place, you can take bromine also. NH3 reacts with bromine, Br2. 8, this is 3, this ammonia is excess. And converted into 6 moles of ammonium bromide plus N2 gas. When this ammonia reacts with bromine, excess of bromine. Excess of bromine means all hydrogen atoms are replaced by bromide ions. Then it is 3 moles and enough, then forms NPR3. Nitrogen tribromide plus 3HBr, hydrogen bromide will forms. So this is about ammonia reacts with halogens. When ammonia reacts with excess of ammonia reacts with chlorine or bromine, liberates hydrogen gas. Excess of chlorine reacts with ammonia, form nitrogen trichloride. Excess of bromine reacts with ammonia, forms nitrogen tribromide. Tribromide means trihalides they forms. Okay, these are the important chemical properties of ammonia. And ammonium ion or ammonia identification test or ammonium ion identification test in inorganic chemistry or in salt analysis. Already we are know that in first PUC we did for the cation and anion analysis of ammonium bromide salts and ammonium chloride salts. So what is the test for identification test for ammonia? That is Nessler's reagent test. What is Nessler's reagent? K2HgI4. K2HgI4 is called Nessler's reagent. It is used for the identification of ammonium ion and they forms a brown color precipitate. When ammonium ion is present in the given salt, they forms brown PPT. Okay, so that is the Nessler's test is used for the identification of ammonium ions. So these are the important points related to ammonia. Let's see important compounds of nitrogen, that is nitrogen oxides. See, in these nitrogen oxides, one important preparation method and the structure of nitrogen oxides we need to discuss. Okay, nitrogen oxides. Nitrogen oxides. What are the important nitrogen oxides are present? We know very well nitrogen conforms different types of oxides. They have that oxides with +1 oxidation state to +5 oxidation state. And N2O, nitrous oxide, in that nitrogen oxidation number is +1. NO, nitric oxide, nitrogen oxidation state is +2. Next, N2O3, nitrogen oxidation state is +3. NO2, +4. That NO2 is unstable and is immediately on cooling is existing divalent form, that is N2O4. We also having +4 oxidation state. And one more is nitrogen pentoxide, N2O5, in which nitrogen oxidation state is +5. So what are the important nitrogen oxidation?